Yeah, that's fine.
I gotta share.
We can't turn the piece of paper.
Yeah, you can.
Okay.
Yeah, they're just online. Okay, well, that totally just about fell off there. Okay, so we're gonna go ahead and get started on it and see how you guys did with it. The densities have a little bit of a range. Okay, so there's a little bit of a range, but I know how close and how bad that range is. So Reese's, anybody do a Reese's?
No.
Twix.
Oh.
Yeah, I did.
I did.
Okay.
Oh, honey, you did.
Kit Kat.
Yeah, I did.
Milky Way.
Yeah.
Snickers.
Yeah.
Okay. So I'm gonna take these, and that should be all we have right now.
Mrs. Sorensen, is your first name Karen?
Yes. Yeah. Don't send it to Megan or Mackenzie. Those are my daughters, and
I'm sure they just love to see this.
yeah. Okay. All right. Ready? So I start with the Snickers. If you thought the Snickers was going to float, raise your hand.
I didn't do it.
Nobody. Okay. So we got some floats.
There's something.
All right. Here we go. And sank. The Snickers sinks. That means it should have a density over 1. It's actually about 1.7-ish up to 2 something. Okay. Twix.
It will flow.
Oh, yeah.
Okay. Float or sink?
Flow or be in the middle.
Sinks.
I think
The
we
top
got
sinks.
it.
Sinks over 1.
Why didn't you change my
Milky Way.
It's
Float.
Oh.
Float.
I'm saying Kit
Watch
Kat.
them all sing.
Sank.
Jack, I'm saying this.
Do the Kit Kat wrapper.
I got 0.8. Yeah, the rapper.
Kit Kat.
Measurements.
Oh, I only did one. I only did like one of the individual.
Yes, I said float.
Kit Kat floats. Kit Kat's about 0.79. Okay.
I got 0.7.
So that's okay. That's good. I told you there's lily weight. Okay. Now here's my question though. What if I break the Kit Kat in half?
It's
Okay.
good.
Oh,
Float
yeah.
still.
Because density doesn't matter how much you have of it. It stays the same no matter what you do. So I don't care if we take a Kit Kat that's king size. It's still going to float. Okay. Now, problem with Isaac saying squishing it, is that going to make a difference? Yes. Okay? Because if you squeeze the air out of your, like the Three Musketeers, even your Milky Way, those sink way more. Okay? So those sink faster. Your mass isn't going to change, but your volume is. So if your mass you had all of a sudden has less volume, it's going to be way more dense, and so they sink faster. So we can take Milky Ways, and we can, Three Musketeers, sorry, and get them floating, and then we can squish them and get them to actually sink. Okay? So my question then, out of these bad boys, okay, this is the part I hate.
I'll eat them.
Which one sank the fastest out of these guys?
The one that I thought was gonna float.
Which one?
The Snickers.
The Snickers, which
I'm
I
so mad
think
about that.
is this one. That one sank the fastest. Okay. So then between our Twix, let's do a race between the Twix and the Milky Way.
Twix almost flooded in my opinion.
Milky Way one.
Move, chair.
Okay, so here's what we're gonna do then. Is there any way that I can get the Twix to float?
Yes.
How?
Like, putting an airplane on it.
That's it?
Putting it on top of the
Do what?
The water denser.
Make the water denser. What's a way I can make the water denser?
Salt.
Salt. Okay, so we're gonna take some salt.
Whoa, that's a lot of salt. That's a lot of salt.
Okay.
Jesus, keep going.
How much money does it take?
I'm gonna fail.
It's not what I wanted, but I'll use this. Okay. So we'll stir that up.
You're not using the right tool.
I know I'm not. What tool should I be using?
Stir rod.
Very good. A glass stir rod. Instead, what am I using? A test tube brush. Okay. Now, as I look at this and I'm looking at it in the camera, I can still see that it's pretty cloudy. So here's what that means. Listen in the back, boys. Okay. If it's cloudy, if something blocks light, it means that it's not a pure, nice, homogeneous mixture, which we're going to start talking about today. What it means is that there's enough particles separated in there that when light hits it, it splits. Okay, so like fog is not homogeneous. It's not all the same. It's actually heterogeneous. So why I'm looking at this is because if that still looks cloudy to me, that means I have quite a bit of salt left in there to dissolve. So I'm going to check it out.
What the heck?
It's flanking, right?
Yeah.
So how, if he's flanking, how do I get him to float? More salt.
Yeah. You just sunk him.
He's dead. He's sunk
Yeah,
like
it's
Adam.
stuck. Can you come back up?
You see me right round the correct.
Still flanking.
Yep.
No.
Now
Come
floating.
on, buddy. Yeah. You got it.
Does that?
No.
So take a look.
Yeah, it doesn't look
He's
right.
actually above.
Oh yeah. This just does not.
Wait, it's like Caddyshack. It's like the candy bar in the pool. Okay,
Yeah.
that looks okay. Now take a look. He is now completely above the water. Okay, so the thing about density is that it's the same no matter the amount of it. Okay, but if we add more things to dissolve in there, then those items become more dense. So what if now I would add more water in here? What would happen?
It's would sink.
So now if I start adding some more water,
Oh, it's sunk like that.
It's
Wait, no,
he's starting to flake.
No, it doesn't.
Yes, it does.
Who? Yeah, it does.
Yeah.
It depends. It actually depends. It depends on how healthy you are, if it floats or sinks.
So if you're not healthy, it'll sink.
It
Wait,
depends
what are
on
you
how
guys
dense it
talking
is. Poop.
I'm like,
Okay. So, right now, we've got the guy floating still, but if we were to go put him in with some more, put more water in there, I'm just running out of space in my beaker, you would get him back to the flinking and the sinking. Okay, so the big thing that you want to look out of this is that density is the same no matter what the size of the object is, but how we can alter those densities, okay? So, I'm going to stop our video here. Maybe if I can find it. So now, here's what I need on that document. Okay, I'll stop the video as soon as I can find where it is. Holy cow. I think it's still recording my,
What am I